Hello, today I want to talk about the right circular cones intersecting in a conic section in the plane. This is inspired by a math stack exchange post. It's given a conic section, an ellipse. I want to find the right circular cone with apex angle pi a over 8. Okay, I tried to answer this by looking at the cone of this form. Whoops. It has if you set z equals 0, it's this original ellipse, and if you want this to be a cone, you need 4 by 4 matrix from when you homogenize with W to be have determinant 0, or the rank of this quadratic form is not the complete 4. Okay, so I tried making a Maxima computer algebra system script for this, and it uses the following equation of a right circular cone. So here nx, ny, and z are the components of a unit vector along the axis of the cone. Theta is this apex angle. And the right circular cone is the one for which theta is pi over 4. So this means that if we take the equation of, say, an ellipse in the plane and take its coefficients to be a, b, c, d, e, and f, so that we have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Then we make a matrix. Of the quadratic form, 4 by 4 matrix, where we have the W in. So this has A and B halves and C as the top 2 by 2 minor, and consists also of this A, capital B, capital C, and capital D for the said these that will vanish when we intersect the cone with the XY plane. Then the miracle is that C enters into this with a linear term, so we can solve for it. And we get, as in the post here, the equation and something that involves AA square AB, B square and D square, and said A, B, D. And then to find the apex, that's the singular point of the cone. So you take the differential with respect to x, y, and z, and solve for x, y, z. And then you get the apex. And now we need to translate the equation of the cone to an equation with this apex at the origin. So then we have to add these apex coordinates, because if we go back again, we have to subtract them. So this equation is, when we have the apex at the origin, needs to be the same equation up to a constant k. This is the square of the cosine of pi over 4, the sum of the squares of x, y, and z, and then the components of the unit vector along the axis of the cone in a product with x, y, z square. So now the coefficients of the difference all need to be 0. This equation 4 is the difference. So we take x squared, y squared, z squared, xy, xz, yz. And remember that it's a unit vector along the axis. And so for a capital A, capital B, capital D, the components of the unit vector and the scaling factor between the equations. So we get several solutions for this, 4 usually. And which one we get, you specify in the as an argument to the function right circular cone. And we specify C as quote C so that we can again make the matrix with now the solutions for A, capital B, capital D, and solve again for C in terms just as above. Now our equation 6 here will be the equation of the right circular cone. So let's try with very simple ellipse. This is the ellipse that let's see, I can show it in GeoGebra. So in the plane, XY plane, we have the slightly, it has the one here, one here, one here, one here. And two of the cones that intersect it in the plane that are right circular. Yeah, so the four equations we easily get by taking the first four solutions of the system we specified in the function right circular cone. This I tried to generalize how to draw tangent circle using cones as summary of math exposition 1 entry with this, and I'm not quite there because if we go back to GeoGebra, if we take the two below, that they intersect in a GeoGebra doesn't know how to intersect these, by the way. It just says intersection circle empty set, which is wrong. If we have general if we have two ellipses, say, in the plane, and we take one cone for each of them, then they right circular cone. Then we get an elliptic curve as an intersection of the two cones. And if we project this down to the plane, to see if we get interesting. That's still not solved using GeoGebra, and I have more work to do in Maxima computer algebra system. I'm leaving this out there before it's finished, but it might interest some people. Bye.